This is part 4 of the videos for Chapter 3, Decisions. In this video we will continue talking about compound conditions and logical operators. We'll talk about the precedence of logical operators within the group of logical operators. Also the precedence of a mix of logical, relational, and arithmetic operators. We will introduce the notion of scope, and we will show you the first feature that C++ has for the programmer to create his own data types. Alright, this is a reminder. If we wanted to check the ranges if a value is within a range, we saw last time we had to form a compound condition, which consisted of a relational expression, and a logical operator being applied to them. So let's introduce formally the logical operators. There are three. Notice that the AND symbol the operator consists of two ampersands, or the operator is two vertical bars next to each other. And we'll see what AND means in a moment. And we introduce also a unary operator. Unary simply means that the operator not only takes one thing. If you give it the value true, it produces the value false. If you give it an expression that's false, it produces the value true. So here are the rules, like a truth table, that says what forms true. It takes two truths to produce the true using AND. Only true and true produces true. Alright, down here, true and false produces false, false and true produces false. False is also produced by ORing two falses. It's produced also by negating or saying not true. With an OR, if you look at this carefully, an OR is true if one of the two operands is true. When both are true, it's true. When the first is true, it's true. When the second is true, it's true. So those are basic rules. And you can see from this table that if x is y and y is 5, x is greater than y, so that's true. Is y greater than z? 12 is greater than or minus 4, that's true. So we have the case of true, and so on. Alright? Now how do we do the bottom one here? Notice that we have a parenthesized expression. It means we must do this first. X is 12, z is minus 4. Is x greater than or equal to z? And the answer is yes, that's true. But we want to negate it, so that will produce a false. What if you have this expression? Notice that we have a relational expression, a relational expression, a relational expression, and what is the precedence? That is, which ones of these do we do first? And the highest precedence is a not. So if there's a not, you do it first. Otherwise, you do all the ands. So we begin the evaluation here. But what has to occur first? Before we do the and, we must do each of the relational operators. This will be false, and this will be false. We learned before that false and false produces false. Now what about this? This is done next. Is 2 less than 3? That's true. So we end up with true or false. And what was our rule? True or false is true. Alright. And if you have a mixed situation, notice that this is an arithmetic expression, addition. This is a relational expression, and this whole thing is relational expression. So the way that we evaluate this is to do arithmetic first, so that basically says 8 is less than 9, and then do the relational operators. We typically do them left to right. So 8 less than 9 is true. 5 equals 6 is false. So we have true or false, and as we've seen before, that produces true. Alright, there's a concept in programming about variables and how long they live. And the rule is pretty simple. A variable only exists after you declare it. So that's the first part. The second part is that After you declare it, the variable only lives until you reach the end of the block where it was defined. Right? And the basic scope rule is you must declare a variable before you use it. And if you look carefully, most programs have all the variables at the top to ensure that they are declared before we use them. All right. Now, if you define a variable inside of a block, those variables are called local variables, and their lifetime is limited by the block. When you leave this block, if I were to say int x and some more stuff, once I leave this block here, the variable x no longer existed. A variable can be defined outside of a block. For example, when you first say pound include and before you say int main, you can declare some variables. Those variables, because they are not defined inside of a block, are called global variables. And they exist from the point that you declare them to the end of your source code. If I have two blocks nested inside of each other, the block that's on the inside is free to create its own variable with the same name as those in the outer block. Probably not a good idea, but it is allowed. And when you're inside the inner block, the only variable that you can really see is the one that you defined inside the block. Now, C++ allows us to define our own data types. As you recall, we have built-in data types. We have ints, we have floats, we have characters, we have strings. All of those come with the language. But you can declare your own data type. And the easiest form of a created data type is called an enumerated list. And the example is this. This example. I am creating a data type called fruit, and I am listing or enumerating the possible values. So when I say fruit, it can either be an apple, a grape, or an orange. Notice below this we have another data type that we are creating. The data type is called days, and I am creating 5 possible values for days. Okay. Notice that these are values. This is a value. The value is the word apple. The value is the word grape. The value is the word orange. Right. Now, we can declare variables of this type. We have just created a data type called fruit. This is creating a data type. And we can use the data type and create a variable. So I have a variable called snack, and it can hold the value of one of the possible values of fruit. So I can assign orange as my snack. Notice that I don't have to put quotes around it because the word orange is actually the value. If I have a work day, I can declare 2 variables for days. One is a work day, one is a vacation day. And I can compare whether work day is Wednesday. All right? And again, I still need no quotes for that. The secret to this is that when you create an enumerated data type, C++ associates numbers to those words based on the order in which you list them. So when I listed the values of my fruit data type, 0 is associated with apple, 1 is associated with grape, 2 is associated with orange. Because of that, I can say things like apple, the word apple is less than grape because 0 is less than 1. All right? You can also define your data type where you specify what values you want to use instead of the default assignments. Now, there are some limitations on the enumerated data types. Their greatest benefit is inside the program, instead of writing numbers for things, you can give names which make the program easier to use. However, enumerated variables cannot be read into. You cannot do input on these variables. If you attempt to output them, for example, if I say output Thursday, what comes out is the associated, the value, the numeric value that's associated with Thursday. All right. Notice one more thing, that the default values are assigned starting with 0. The first one has a value of 0, 1, and 2. All right. Now, one other thing is really important to note, that here's a word and behind it is a 0. Here's a value, orange, behind it is a 2. So you might see that whenever you create an enumerated data type, you're really creating a data type that's another kind of integer, because these are all whole numbers. All right? So we will use enumerated data types later. Finally, I want to show you some old-fashioned way of making a decision. And let's take a look. Question mark means you're asking a question. What question are you asking? You want to know what the result of some expression is, and you want it to be true or false. If it is true, you want to put the consequence. So this expression says, what do you do for the consequence? And this expression says, what do you do for the alternative? All right, more on that. At this point, we will stop